Hi, today we are going to learn about first order kinetics and its derivation and half-life also. We try to say half-life and shelf life also. So, first to know what is the order of kinetics. Order of kinetics is number of concentration terms. Let's say A plus B is reacting to give C product. So, number of concentration terms of reactants on which the rate of reaction is dependent, we call it as order of reaction. So, if the rate of reaction is dependent on the concentration terms of only one reactant, we call it as first order. If it depends on concentration terms of two reactants, we call it as second order. If it is dependent on the if it is not dependent on any concentration terms, then we call it as zero order kinetics. Here, because it is dependent on the concentration of one reactant, we call it as a first order kinetics. What is rate of reaction? We denote it as dC by dt. So, we start with the derivation. So, rate of reaction is dependent on the concentration terms of one reactant, hence I am writing here C. As reaction proceeds, the reactant concentration will get decrease. This dC by dt is the change in concentration of reactants, not the product, it is reactants. As the reaction proceeds, the concentration of reactant will decrease, hence to represent that I will denote as negative sign. So, here the rate of reaction is directly proportional to one concentration term. So, I am writing C here. So, we try to rearrange this equation. Remove the proportionality constant, we will put some constant, we call it as a K1, because it is we are talking about first order kinetics, we will keep it as a K1 and your concentration. Now, I want to integrate this equation. For the purpose of integration, you can't integrate different terms here. So, you need to integrate only same terminologies. I want this C to come here and dt to come there. So, rearrange the equation, you will get dC by C into K1 dt. After rearranging, we try to integrate left hand side and right hand side. Left hand side is integrated from C0 to Ct. So, it is integrated because it is concentration divided by difference in concentration divided by concentration, it is integrated from C0 to Ct. Yeah. Now, dt is been integrated from 0 time 0 to time t. So, this is how we integrate this. If you integrate this one, there is a equation called, if you integrate dC by dC from C0 to Ct, the equation is Ct minus C0, that is natural log Ct minus natural log C0. So, substitute this equation here. So, assume this is as equation 1, this is equation 2, substitute 1 in 2. What you will get? Minus natural log Ct minus natural log C0 is equal to t minus 0. So, k t minus 0. Now, multiply this negative side to this equation, then the equation will be rearranged like this. Natural log C0 minus natural log Ct is equal to K1 t. Now, there is another equation, natural log A is equal to 2.303 log A. So, if you want to convert the natural log to log base 10, this is the equation. Assume this is equation 3 and this is equation 4. So, substitute 3 in 4. What I will do is natural log C0 minus Ct can be written as natural log C0 by Ct, which corresponds to log A minus log B is equal to log A by B is equal to K1 t. Now, we will move on here. So, substitute this equation, assume this as equation 4, substitute this equation 3 in equation 4. What you will get? 2.303 log C0 by Ct is equal to K1 t. This is the equation. We need to solve. We are deriving the equation for rate constant. Hence, K rate constant is equal to 2.303 log C0 by Ct. This t will come down. T is equal to K. Rewrite the equation. So, K1 is equal to 2.303 by t into log C naught by Ct. This is the equation for first order kinetics. We try to see what are the units for this. So, there is no units for 2.303, it is just a number. C naught by Ct is there. So, concentration by concentration will get cancelled. We will be remaining with only the concentration. The only thing which is remaining here is time. So, K units is per second. These are the units of your first order kinetics. We try to see half life derivation. So, T half. What is T half? It is time taken to reduce the concentration of reactants to half of its initial concentration. So, initially the concentration is C naught, at T half the concentration will be C naught by 2. So, initially the concentration will be C naught, at T half the concentration will be C naught by 2. This is what the definition says about. So, substitute this equation in this one, assume this as a fifth equation, this is sixth equation, substitute this one, what you will get? K1 is equal to 2.303 by T will be taken as T half. So, log C naught by Ct. Ct will be now what? C naught by 2, because at T half the concentration will be C naught by 2. Rearrange this equation, what you will get? 2.303 by T half into log C naught will get cancelled, this 2 will go log 2. So, what you will get? K is equal to 2.303 by T half, log 2 is 0.3010. Take this one, rearrange the equation, T half is equal to 2.303 by K into multiply 0.3010. If you multiply this 2, you will get the equation T half is equal to 0.693 by K. So, this is the equation for half life for the first order kinetics. We will try to see about shelf life of the first order kinetics. So, this is the equation for the first order kinetics, it is Ct. So, remember what is shelf life definition says? The amount of time required to reduce the concentration to 90% of initial concentration. So, C naught will be C naught at initial concentration, at shelf life your Ct will be 0.9 C naught. So, if it is 1, this is 100%, so 90% will be remaining. If I convert that into points, it will be 0.9. Assume this as a 1, 90% of 1 is 0.9. So, that what is your shelf life definition says about. So, substitute this equation here. So, what you will get here is 2.303 by T 90%. We represent shelf life as T 90%. So, log C naught by 0.9 C naught, that what I am substituting. Ct is substituted 0.9 C naught. C naught will get cancelled. What we are remaining is 1 by 0.9. What is 1 by 0.9 is 1.111. So, K into 2.303 by T 90% multiplied by 1.111, sorry, log 1.111. If you convert the log 1.111 and multiply this corresponding thing to 2.303, what you will get is 0.105 by T 90%. So, reverse this, rearrange the equation, what you will get? T 90% is equal to 0.105 by K. So, this is the equation for shelf life of your first order kinetics. That what the explanation. I hope you understand. Thank you.